Hey, what's up everyone? In today's video, we will be taking a look inside a loudspeaker, and then we are going to have a short discussion on how a loudspeaker works based on what we have learned about electromagnetism in topic 21 of O-level physics. This is a very old loudspeaker system, as you can probably tell. Now, this is a subwoofer, meaning that it is supposed to take care of the low frequency sounds. It actually has some connections here that are supposed to be connected to some smaller speakers which will take care of the high frequency sounds. Okay, if we open up the speaker, on the inside we see that there is some circuitry and this thing here, which is the speaker cone, right? If you take a look at the circuitry, some interesting things to take note of. Now, basically this circuitry just takes care of the signal which is sent from the signal source to the speakers. Mainly what it does is it splits the signal into high frequencies and low frequencies. The low frequencies will be then sent via this cable to this speaker cone here. Okay. Now we'll touch on that later. Now, one thing I want you to take note of is, I hope you can see here that there is a fuse on the inside. Now, the fuse is one of the electrical safety devices that we learned about in topic 19, practical electricity. Okay, that's somewhere over here. It looks like a glass tube with a wire inside. Okay, so the main component of the speaker that we'll be interested in is the speaker cone. Okay, so I'm going to take this out now. So as you can see, this speaker is pretty old. This is a PC speaker from back when I was in secondary school. And if we open it up, this is what it looks like. Okay. So over here we have some circuitry. This circuitry will basically just take the signal that is being sent via the connecting cable here and split it into a voltage signal which will be sent to the respective speaker cones. Okay, and what I mean by speaker cone is this thing over here. Now hang on, let me unscrew this first. Alright, yes, so now I've taken it out and this wire actually connects to the circuit board, and the circuit board will be sending a voltage signal to this. Now remember that sound is a series of compressions and rarefactions, right, in a longitudinal wave that is being propagated. Now, in order for a sound wave to be produced, you need to have a vibrating object. Now, this speaker cone is the thing that is in charge of producing the vibrations. And basically what happens is when a signal is being passed through these wires, something happens to make this speaker cone vibrate in exactly the right way to produce the sound wave required. Okay. Some other parts to note, note that over here at the back of this, you see that there's two really quite strong magnets that we have at the back here. You can see they are attracting the screwdriver quite strongly. Okay. So if you just give me a moment, I'm going to connect this up and show you what this looks like when it is vibrating. So now it's all connected up. All I have to do is turn on the power, and once I start the signal, you will see this thing start vibrating. Now it's vibrating. I've set the signal to 100 Hertz. So right now, you probably just see a blur because the speaker is actually moving in and out at 100 times a second. That's what 100 Hertz means, right? And that's the sound that you're hearing now, right? If I place my mic near to it, you can hear it. Okay, so in case you can't see the vibration, we can demonstrate that this thing is vibrating very quickly by just pouring some objects on it. Over here I have some barley seeds. Oops. Okay, maybe the vibration is a little bit too strong. They are all bouncing off. Maybe I can try to turn it down to a lower frequency. Oh, at 20 Hertz, probably you can start to see that it is vibrating, right? So you will remember that 20 Hertz is actually the lowest frequency that you can hear. In the next part of this video, I will be showing you on the slide how it is that we can use the electrical signal to specify exactly how this cone is supposed to move. Okay, so let's move on to the slide. Okay, so now we're on looking at the slide. If you take a look at the slide here, on the left side, we have a 3D cutaway of what the inside of the speaker cone looks like. So as you can see, like earlier, we saw that there's this main cone structure here. Okay, and on the inside, what we have is actually a structure containing a magnet. And as well, notice here that there's this thing called a voice coil. Okay, now from this diagram, it's not very easy to tell how this works, but if we simplify it a little bit and take a look at a simplified side view, this is what we will see. So basically, there's a magnetic structure. Okay, now this provides a permanent magnetic field, which this voice coil over here is placed within. Now this voice coil is attached to the cone section of the speaker, the moving part of the speaker that creates the vibrations. Okay. And if you look at an even more simplified front view, what happens is the coil is represented by this circular arrow here, and the magnetic structure basically creates a magnetic field that is radially going from the inside to the outside across the coil. So let's say if this was the North Pole and this outside was the South Pole, then what you would see is that there is a magnetic field pointing outwards like this along the radius of the circle, something that looks like spokes of a bicycle wheel. Okay. So what happens when the signal is sent to this coil? A current will run. So in this case, you can see that the current is directed in the anti-clockwise manner. Okay. So let's say we were to look at this portion here where the magnetic field is pointing downwards. Okay. If we look at the current at this point where it crosses the magnetic field, the current should be pointing in the direction that is tangent to the circle at this point, right? So the current direction at this point of the circle is tangent to the circle, which means that it's pointing to the right. Now, if we use the Fleming's left-hand rule at this point, we can arrange it like this, and you will see that the force direction is pointing into the page, right? It's pushing the coil backwards away from you, okay? Now, in the context of the side view, this means that when the current is flowing in this direction, it's going to push the speaker cone back this way, okay? So you can see that by adjusting the amount of current and the direction of the current, then we can push the cone either backwards this way or forwards in the other direction, right? By reversing the direction of the current. What's happening when the speaker is running is that the current that's being sent to the coil is very carefully controlled by circuitry in the speaker. Okay, and it is going to switch back and forth very quickly. This will control the exact vibration of the speaker cone back and forth, okay, which will then cause the air molecules around it to vibrate, and that basically is what sends the sound wave outwards. Okay, so I hope you found that useful. Please like, subscribe, put a comment, let me know what you think, and see you in the next video. Thank you.